Good morning to all. Today we are going to see about laser modes. The outcome of this topic after completion of this section, the students able to understood the laser modes. The laser cavity is also very important for laser in many other aspects. For example, if dimension decides the longitudinal laser modes. Generally, the speaking light modes means possible standing EM wave in the system. The number of modes in the meaning in hues, the laser means the possible standing waves in laser cavity. The number of modes in the meaning in hues, the laser means is possible the student's waves in the laser cavity, where L is the length of cavity, C is the lighthouse speed, and laser cavity, F is the frequency standing wave, L is the wavelength, M is an integer, D is the frequency difference between the two consecutive modes. The modes are standing oscillating electromagnetic waves which are defined by the cavity geometry. In the above section, we have already computed the longitudinal mode frequency for some simple cases. If the cavity is closed form, that is both mirror and the side walls are reflective, there will be a large amount of longitudinal modes oscillating inside the cavity. A typical value can be 109 modes for the helium neon laser. When these modes oscillate, they interface with each other, forming transverse standing wave pattern on my transverse interaction plane. This mechanism decides the transverse electromagnetic modes of laser beam, which is wave pattern on the output aperture plane. We use the sign term to specify a term mode where P is the number of radial zero field, Q is the number of angular zero field, and we usually term PQ to specify a term mode without third index. A table of term pattern is shown below. Clearly, the made pattern aspects distribute of output beam energy, which will thus affect the machine process. The diameter of laser beam usually defined as the distance with the L by E2 of total power exits. The higher the order mode, the more difficult to focus the beam to find spot. Since the beam of order is not from virtual point but pattern this table below. When this mode oscillate, they interface with each other, forming the transverse standing wave pattern, one or transverse intersection plane. The focal spot size determines the maximum energy density that can be achieved when the laser beam power is set. So, the focal spot size is very important for material processing. When the beam is finite diameter d is focused by a lens on a plane, the individual part of the beam striking the lens can be imagined by the point radiator of new wave front.